Assalamualaikum and hi everyone. So today we are going to continue with the second topic, which is on problem solving concepts. The overview, we are going to look into problem solving in everyday life, different types of problems using the computers in problem solving, and also the difficulties that we might face due to the complexity of it. Before we start to write our Java code, it is important that we identify and think through the steps to solve it so that we can ensure that our program and our code is optimal and we can minimize duplicating any part of the code. The most important skill for a computer scientist is in problem solving. So problem solving is the ability to formulate problems, think creatively about solutions, and express a solution clearly and accurately. Programming involves two steps. The first one is problem solving, and the second one is translating the solution into code. So a programmer needs to have the ability to produce the solution, and they should have the knowledge about the specific programming language that will be used. So what is a problem? A problem is the statement of specifications that requires a solution. So problem can either be concrete or abstract. Concrete here means that they have known values to be used in making the solution. For example, compute the area of a circle when its radius is 5.5 cm. We know that to calculate the area of a circle, the equation that we need to use is pi r squared. So r is the radius. So given that we already know the radius, we can calculate it straight away by inputting the value into the equation. So the area of a circle in this example is pi multiplied with 5.5 squared, and we will get 95.03. Another example that we have here is Ali drove to Abu's house at 60 km per hour. Abu's house is 80 km away. Ali arrived at Abu's house at 3:22 p.m. What time did Ali leave? How to calculate this? So using basic maths, we will do 60 km divided by 60 minutes and we will get 1 km per minute. So for 80 km away, it will take 80 minutes, which is equal to 1 hour and 20 minutes. So we're just changing it to hours and minutes. So if Ali arrived at Abu's house at 3:22 p.m., we need to subtract 1 hour and 20 minutes from it. So we know that Ali has to leave at 2:02 p.m. Based on these two examples, we can conclude that in concrete type of problems, we are able to solve the specific problem as the values are known to us. Now, let's look at abstract type of problem. Abstract means that they have no particular values to be used in making the solution, unlike what we have seen in concrete problems. These examples are similar as before, but without having values to calculate them. The first example, it says compute the area of a circle with a given radius. As there is no number to indicate the value of the radius, we can only calculate it as area equals to pi multiplied with radius squared. The same goes for the second example, where we do not know the exact time Ali arrived. We can have it as Ali should leave at arrival time minus 1 hour and 20 minutes. So, in short, in any abstract or general type of problems, they can be used to solve several problems when concrete information is given. For example, in the area of a circle problem, it can calculate the area for any radius values once the radius is known. It can be radius 5.5 as before, 6 or any number. Abstract problems are the more common problem. We'll focus on this. There are two types of problem solutions, which are algorithmic solution and also heuristic solutions. So what does it mean by algorithmic solutions? Most of the problems that we create for computers are algorithmic solutions. Algorithmic solutions are a set of instructions that will be followed each time the program is run. For example, calculating your checkbook balance. Other example can be checking your bank statement or keeping track of incoming or outgoing of your money. So the algorithmic solution in calculating your checkbook balance can have these steps. So the first one, you will enter all transactions into the checkbook register. Second step, review the account statement. Third step, adjust the checkbook register. Fourth, double check everything. And finally, number 5, finish checking the checkbook. Every time when we want to calculate the checkbook balance, we will still repeat the same steps as before. Heuristic solutions, on the other hand, create different solutions each time the program is run. Calculating an appropriate stock to purchase is an example of a heuristic problem because what is appropriate 1 minute may not be in the next minute. This means that even by using the same steps, it may not produce the same result. Another simple example is how to decide which program to choose for your undergraduate study. It is different from one person to another based on their interest, preference, and also other reasons. Artificial intelligence deals with heuristic types of problems where it can adapt to changes to find the optimal or best solution for the particular time or situation. Let's look at the 6 steps in problem solving. So the first one, we need to identify the problem. If we can restate the problem, how are we going to build a program to solve it? It's kind of like algebra problems, solve for x when presented with an equation. If we do not know how to go through the steps to solve it, how are we going to come up with the correct answer? For example, providing someone directions. If say that we give the instruction to someone and we tell them to go north for 500 meters, but the person does not know which direction is north, how effective are the instructions going to be for that person? The second step is understanding the problem. Being able to restate is one way to verify that we understand the what we will be doing, but we have to understand the problem too. One way to figure out the problem is to perform research on the problem. Another method is through observing what do they do without the computer-assisted solution that we are going to develop for them. By observing what they are doing, we can better understand the problem and thus create a better design solution that will serve the needs. Another method is to review past activities. This will give us a historical perspective of what they have been doing and what they want to change about the way they are doing things. For example, in giving instructions to someone on how to find an address, maybe through pointing out landmarks or finding something that people usually will see, such as the roundabout or the house painted in bright red paint at the corner. The third step is identifying alternative ways to solve the problem. Rarely does a problem have only one solution. A simple example is in giving direction. There are many routes that can be taken to reach the same destination. These different routes are the alternative. By creating multiple solutions to the problem, we can evaluate the different solutions to find the one best for that particular problem. Different aspects to look at include efficiency of the code, the speed of the code, the accuracy of it, and also the acceptability of the code. Other factors to consider include the maintainability and reusability of the code. Normally, if you have to write and repeat the same code, that means that your code has duplication, so it needs to be improved. The fourth step is select the best way to solve the problem from the list of alternative solutions. We should create a list of pros and cons for each solution and evaluate how pro and how con is each. then we need to select the best solution based upon the research. The fifth step is we need to list the instructions that will solve the problem using the selected solution. We can create a numbered step-by-step set of instructions to be followed. But it's not just about the list of instructions. We also have to know what the users will know. This is the knowledge base. So a knowledge base is a list of what the user needs to know before the user can complete the instructions created in the computer-aided solution. In other words, if we create a program that gives directions to find a location for users using north, south, east, and west, and they don't know where they are with relation to the compass, our program will be worthless to them. Similarly, if we give them street addresses and they don't know the name of the street, again, the program will be useless to them. We have to be aware of the user's knowledge base or establish one for them before they can successfully use the program. The final step is evaluate the solution. Make sure that the solution is accurate, it solves the right problem, and it also satisfies the need of the client or the user. Problem solving with computers. So problem solving with computers need to have the solution, which is the step 5 from previous slide, where it lists the instructions to produce the best result. It says the best result because in step 4, we have selected the best way to solve the problem from the list of alternative solutions. Result here refers to the outcome from the program that we have created or code that we have written. A program contains the instructions for the solution written in the selected computer language as code. There are 4 basic steps in building a program, which include the first one, analyzing and understand the problem, developing the algorithms to solve the different components of the problem, writing the program in a particular language appropriate to the problem, also writing the documentation for both programmers and users, and finally testing the solution by debugging the solution by the programmer and also by other users. So the first step is analyzing and understanding the problem. What would be considered the input data? Using the direction example, the input data might be how to get to UUM, for example. What would be considered as the output information? This can be the routes that should be taken to get from our current location to UUM. And then what are the formulas or processes that you have to create to solve this solution? This can be maybe what is the time to leave or arrive at UUM. And also, are there any special conditions or constraints? For example, getting to UUM without using the highway or the expressway. By going through these questions, we are able to understand the problem and think on how to solve it. Basically, in problem analysis, we have the inputs, and based on the input, we will do some processing such as deciding on the routes and then produce the output that is able to solve the problem. The second step is the algorithm. We can write the algorithm in Pseudocode or Flowchart. We will learn about this in the next few slides. Once we have written the algorithm, before writing the code, we need to test the algorithm first. This is done to ensure that we have the correct steps. If we straight away write the code, we might have to rewrite the code all over again if our algorithm is not optimal. It is much easier to detect any mistakes from the algorithm rather than in the code, which can be hundreds and thousands of lines. To test the algorithm, we can do it manually. Pretend that you are the computer and follow the steps of your algorithm while keeping track of how the variables are changing. Step 3 is coding. We can develop the program By coding the algorithm in any language such as Java, we need to have the knowledge of the programming language in terms of the language syntax. We have seen before that Java, C, or C++ are slightly different in the way that they are being written. We can also use IDEs such as Eclipse and NetBeans to write the code. However, you can always use Notepad if you prefer that rather than using the IDE. The last step, which is step 4, is testing and debugging the program. The test is done to verify that the program meets the requirements by creating test cases. This means that from abstract problem, we turn it into concrete, where we can provide some values. Tests can avoid bugs such as logic errors that is due to human mistakes. In the previous slides, we heard the word algorithm. So what does it mean by an algorithm? An algorithm is a clear step-by-step sequence of instructions to solve a problem. For example, this slide shows the algorithm, which is the step-by-step to bake a cake. We would first heat the oven, gather the ingredients, mix it, pour it into the baking pan, bake it, repeat it again, and finally cut the cake to be served. Similarly, in any program that we want to write, there are steps that need to be followed. There are two ways to represent algorithm, which are pseudocode and flowchart. We are going to learn both of them. Pseudocode is using English-like statements to list the steps to be taken in the solution. Flowchart is by using diagrams that employ symbols to describe the workflow of steps involved in the solution. Pseudocode statements usually perform input, output, and processing, for example, any arithmetic operations. The input statements are to get the data to perform the computation. For example, inputs to the name, mark, length, or width. The output statements are to display information for the user. For example, output the sentence, enters to the name, output the value of the final grade. Example of processing is doing some kind of arithmetic operations, such as calculating x plus y. Pseudocode can be seen as the unrefined or draft of your code without writing the proper code yet. It closely represents the flow of your code. Let's look at this example. Price average equal to price 1 plus price 2 plus price 3 plus price 4 plus price 5 divided by 5. These statements represent arithmetic assignment statements. The right side of the statement is the arithmetic expression using the standard mathematical notation. The left side is where the result of the computation is stored for further processing. This might take a bit of time to familiarize yourself with the format, as typically in mathematics, we will do the calculation at the left side and the final value is at the right side. In programming, it is the other way around. Let's look at this example of how a pseudocode looks like. Say that we want to calculate the perimeter of a rectangle. To start off, we need to write start. Then, as we want to display something, we will use output. What do we want to display? We want to display the sentence enter rectangle length. Next line, we want the user to enter or type in the value of the rectangle length, meaning that we are expecting an input. So, we will write input length. Then, we want the user to enter rectangle width. So, we will write output enter rectangle width. We expect an input, so we write input width. Next is the process, which is calculating the perimeter. So we write calculate perimeter equal to 2 times with length plus width. Then We want the result to be displayed, so we write output parameter, which refers to the calculated value from the previous line. When we are done, we have to write end at the last line. It can also be stop, which still refers to the same thing. We'll do some exercises on this to ensure that you understand on how to write a pseudocode. Now let's look at Flowchart. Flowchart has the same flow as pseudocode, but it is a graphical way of depicting a problem in terms of its inputs, outputs, and also the processes. The basic elements are as shown in this slide. For start or end of a program, we will use a rounded rectangle. We can also use a circle or an oval. Input and output is represented by parallelogram. Any processes, such as arithmetic operations, will use the rectangle shape. Diamond is used for decision, which we will use when we learn selection and repetition topics, which are the if-else, switch, while loop, do-while loop, and also for loop. All of these elements and shapes will be followed by arrows to show the execution flow. Referring to the same question and pseudocode that we have written before, we can draw our flowchart. We have our start in the rounded rectangle, or a circle, or even an oval. We have our output and input in parallelogram, and then our process in rectangle. And finally, our end in a rounded rectangle, circle, or an oval, the same as our start. In the process, instead of using the equal sign, we can also use arrow, which means the calculated value will be kept in the variable called parameter. Previously, we wrote output parameter. That means that in our code, it will display the parameter value straight away. By writing output parameter is and then parameter, the output here will have the sentence, then only the value. For the same question, depending on our style, we can also write the pseudocode and flowchart as shown in this slide. Here, we combine the length and width where we want the user to enter both values, which are the input at once. Overall, they still do similar things as before, which is to calculate the rectangle parameter. We can also write it this way. Keep in mind that when we start our pseudocode or flowchart with input, that means that the user will not see any display of any sentence. This can be confusing to the user because it does not state what values are expected. It does not show any sentence to be displayed. In this slide, you can compare the slightly different ways of writing the pseudocode as what we have seen in previous slides to calculate the parameter of a rectangle. Similarly, you can also compare the flowchart of those. To summarize, we have looked at the two types of problems, which can be concrete that has known values and also abstract that does not have any particular values. We have also looked at the two types of problem solutions, the algorithmic and heuristic solutions. Algorithmic solutions have a set of repeatable instructions, while in heuristic solutions, it might produce different results each time. We have also covered the 6 steps in problem solving, from identifying and understanding the problem, alternative way to solve it, selecting and listing the steps of the solution, and finally evaluating it. Then, the 4 steps in building a program. As part of the process in building a program, we have learned to write the algorithm using pseudocode and also the flowchart. That's all for this topic. We will do some exercises related to this to ensure that you understand and know how to write pseudocode and also draw the flowchart. I will see you in the next topic.